There are moments in human history when the sky transforms from a mere backdrop into a subject of discourse. As you're absorbing this, an event is unfolding beyond the sun, an occurrence hidden from our direct perception. This entity arrived from a distant star system 3 months ago, travelling at speeds that defy natural phenomena. 7 space agencies have classified it as a comet, yet comets do not behave in the manner observable with 3I Atlas. On the 3rd of October, multiple Mars-orbiting satellites documented the object during its closest approach to the red planet. The European Space Agency disseminated their photographic evidence 4 days later, a faint white speck, 30 million kilometres distant. They stated this was the extent of their capability with equipment designed for Martian geology, not for celestial visitors from deep space. However, here's what they omitted. On that very same day, NASA's Mars Reconnaissance Orbiter, equipped with the most advanced camera ever dispatched to another planet, was ideally positioned. Its high-rise instrument can discern objects as small as a kitchen table on Mars's surface from orbit. At a distance of 30 million kilometres, it should have resolved 3I Atlas into structures 30 kilometres in dimension, providing data 10 times superior to Europe's captured images. Those images exist. They were acquired. And as of today, the 19th of October, they remain unreleased. The officially stated justification is the government shutdown. Over 15,000 NASA personnel are on furlough, website updates have ceased, communication channels are frozen, resulting in bureaucratic paralysis at precisely the time when clarity is most essential. Yet, the European Space Agency is unaffected by American political affairs. Neither is China's National Space Administration, nor is the UAE Space Agency. All of them had orbital assets observing. All of them have maintained a conspicuous silence regarding their highest resolution data. If you find this as intriguing and disconcerting as I do, please consider subscribing. This narrative is developing in real time, and the subsequent development might be documented before this video concludes. Kindly share in the comments where you're viewing from, the current time there, and whether you believe we are privy to the complete situation. Chapter 1: The Enigma that Defies Existence. Let us commence with established certainties. On the 1st of July 2025, the Atlas Survey Telescope located in Chile detected a celestial body in motion through Sagittarius. This in itself is not uncommon, as Atlas routinely identifies asteroids. However, within hours, the trajectory of this particular object drew attention. Its projected orbit appeared aberrant, excessively swift and remarkably linear. It was moving at 58 kilometers per second relative to the Sun, a velocity double the escape velocity of our solar system. This was no stray asteroid dislodged from the belt between Mars and Jupiter. It was not a comet dislodged from the Oort cloud by the gravitational influence of passing stars. Its origin lay elsewhere. By the 2nd of July, the Minor Planet Center had confirmed its existence, 3 Atlas. The 3I designation signifies an interstellar origin, marking it as the 3rd confirmed visitor from beyond our solar system. Following Oumuamua in 2017 and Borisov in 2019, humanity has developed a capacity to recognize their signatures, hyperbolic trajectories, improbable speeds, and arrivals from directions inconsistent with objects native to our solar system. Yet, 3I Atlas diverged from its predecessors in significant ways. Oumuamua approached from a tilted angle, 123 degrees relative to the plane of Earth's orbit. Borisov entered at 44 degrees, random angles as expected from objects randomly ejected from distant star systems, drifting through the galaxy for eons. 3I Atlas, however, arrived at an angle of 4.89 degrees, almost perfectly aligned with the ecliptic plane. This is the plane in which Earth, Mars, Venus, and Jupiter all orbit, the plane that defines our solar system's fundamental structure. The statistical probability of such an alignment occurring by chance is 0.2%, or 1 in 500. And this is merely the commencement of the coincidences. When astronomers traced 3I Atlas's path backward through space, they discovered it originated from the direction of Sagittarius, and not just any portion of Sagittarius, but the galactic centre itself. This is the most densely populated stellar region in our sky, the exact area where detecting a faint distant object prior to July 2025 would have been exceedingly difficult due to the overwhelming density of background stars. It is as if the object deliberately chose to arrive when detection would be at its most challenging. The comet is projected to reach perihelion, its closest point to the Sun, on the 29th of October 2025. In 10 days, at that precise moment, it will be 1.36 astronomical units from the Sun, situated just inside Mars's orbit, travelling at 68 kilometers per second. And here lies the crucial detail, the aspect that prompts Harvard physicist Avi Loeb to awaken at 3 in the morning and sketch trajectories on napkins. 3I Atlas will be positioned on the opposite side of the Sun from Earth during its perihelion, rendering it invisible to all ground-based telescopes on the planet, obscured by the Sun during what should be its most active, most observable, and most revealing phase. If one were to design an interstellar reconnaissance probe and desire to operate undetected, this temporal window would be exceptionally advantageous. Chapter 2. The Incongruous Chemistry. Let me elucidate the typical composition of comets. They are composed of water, ice, carbon dioxide, methane, ammonia, silicate dust, and trace organic compounds. These are essentially frozen remnants from stellar nurseries, preserved in the frigid void between stars. Upon approaching a star, any star, the ice sublimes directly into gas, carrying dust particles with it, thereby forming the characteristic coma and tail observed in comets for millennia. The chemistry involved is predictable and universal. We have analysed dozens of comets originating from our solar system and 2 from beyond. While the ratios may vary slightly, the fundamental composition remains consistent. Water is the dominant element. Carbon monoxide is present. Simple organic compounds contribute to the reddish hue often associated with ancient irradiated ices. 3I Atlas deviates from this established pattern. In August 2025, the James Webb Space Telescope directed its infrared spectrometer towards the comet. The JWST possesses the capability to detect molecular signatures with exceptional precision, identifying specific compounds by their absorption and emission of light. What it discovered was unprecedented. The comet's gaseous composition is 87% carbon dioxide, not as a minor constituent, but as 87% of all its emitted gases. Water ice is present, but accounts for a mere 4% of the detectable emissions. For context, typical solar system comets are comprised of approximately 80% water, with carbon dioxide constituting perhaps 10 to 20% of the emissions. This ratio is fundamentally inverted. It would be akin to discovering a human being whose body is composed of 87% bone and only 4% water. Then there is the matter of nickel. On the 21st of August, the Very Large Telescope in Chile detected atomic nickel vapor within 3I Atlas's coma. This is not inherently unusual. Nickel has been identified in other comets, invariably appearing alongside iron in roughly equal concentrations. They form together in supernova explosions, travel together through interstellar space, and are found together in rocky celestial bodies. The anomaly with 3I Atlas is the virtual absence of iron, or at least its undetectability. The nickel-to-iron ratio is drastically skewed, approaching proportions found in industrial alloys, the kind of ratio observed in spacecraft heat shields, not in natural solar system formations. Some astronomers hypothesize this could indicate an unusual formation environment, a star system with atypical metallicity, or a protoplanetary disk exhibiting chemical fractionation patterns yet to be understood. Others point out that nickel-iron alloys are precisely the materials utilized for constructing objects designed to withstand extreme temperature fluctuations and high-velocity particle impacts during interstellar journeys. The data, while ambiguous, carries significant implications. Furthermore, there is the temperature paradox. 3I Atlas is expelling substantial quantities of gas. The outgassing rate measured in August indicated it was ejecting over 100 kilograms of material per second. Such a level of sublimation necessitates considerable heat input. The sun's radiation impinging on the comet's surface should be warming it, driving the sublimation of ice into gas and generating the activity we observe. However, infrared observations reveal the object remains cold, significantly colder than would be expected given its distance from the sun and its level of activity. It resembles observing someone profusely sweating while standing within a freezer. The physics are irreconcilable. One possible explanation is that the object possesses very low thermal inertia, heating rapidly on its sunlit side and radiating that heat away efficiently, thus maintaining an average temperature that appears cold to our instruments. Another hypothesis is that the outgassing is not primarily driven by solar heating. Instead, an alternative energy source might be responsible for the gas release at this rate, an internal heat source, or a mechanism currently unknown to us. The scientific publications are cautiously worded. They note these anomalies, propose further observations, and refrain from speculation. However, in private discussions during conference calls and email exchanges, astronomers are employing a different term: anomalous. Not merely unusual or rare, but anomalous, signifying that it does not conform to any natural model currently available to us. Chapter 3: The Unseen Imagery. Let us address the events of the 3rd of October. 7 spacecraft representing 4 distinct space agencies were strategically positioned to observe 3I Atlas as it made its closest pass by Mars. This presented the most opportune moment for capturing highly detailed imagery. Mars's orbital path placed its array of orbiters between Earth and the comet, offering a perspective unattainable from our planet. These included ESA's ExoMars Trace Gas Orbiter, ESA's Mars Express, NASA's Mars Reconnaissance Orbiter, NASA's MAVEN, China's Tianwen-1, the UAE's Hope Orbiter, and from the Martian surface, NASA's Perseverance rover. Mission plans had been submitted months in advance, observation windows precisely calculated, and instrument parameters optimized. Everything was prepared. Then, the images began to arrive. On the 7th of October, ESA released their photographs. The ExoMars Trace Gas Orbiter captured 3I Atlas as a nebulous white dot traversing a starfield. The exposure time was 5 seconds, pushed to the absolute limit of the Cassis camera's capacity without being overwhelmed by background stars. The outcome was a barely resolved coma, no discernible nucleus, and no structural details, nothing that could not have been captured by a proficient amateur telescope on Earth. ESA's press release offered an apology, stating that this was a highly challenging observation for the instrument, with the comet being approximately 10,000 to 100,000 times fainter than their typical targets. In essence, their cameras are engineered for photographing prominent Martian cliffs from a few hundred kilometers away, not dim comets at a distance of 30 million kilometers. This is understandable. Not every instrument is suited for every task. However, NASA's Mars Reconnaissance Orbiter presents an entirely different scenario. The high-rise camera aboard the MRO is the most sophisticated camera ever sent to another planet. Its angular resolution is so precise that, from an altitude of 300 kilometers in Mars orbit, it can distinguish objects measuring 30 centimeters across, the size of a kitchen table, a small boulder, or individual rocks within a landslide. At a distance of 30 million kilometers from 3I Atlas, HiRISE possessed an angular resolution of approximately 30 kilometers per pixel. This equates to 10 times greater detail than ESA achieved, 10 times more information. If there were structures, geometric patterns, or anything about this object inconsistent with the narrative of a natural comet, HiRISE would have detected it. those images were indeed captured. The observation window was scheduled, the spacecraft was correctly positioned, and the data was collected and transmitted back to Earth. As of the 19th of October, 8 days ago, these images have not been publicly disclosed. NASA's official statement attributes this to the government shutdown, citing over 15,000 employees on furlough, the suspension of website updates, a lack of personnel to process requests, and an absence of staff to draft press releases. This is a plausible explanation for a temporary delay in the release of non-critical imagery, with one exception: 3 critical issues. Firstly, the shutdown commenced after the flyby. The shutdown began on October 1st, while the observations took place on October 3rd. NASA had 48 hours with a full staff complement to begin processing and disseminating time-sensitive scientific data. Secondly, ESA released their images on October 7th. As a European agency, they are entirely unaffected by American political dysfunction. They published their findings within days. NASA could have done likewise before the shutdown took effect. Thirdly, and most importantly, the other agencies have also withheld their most detailed data. China's Tianwen-1 orbiter is equipped with the Mars Orbiter camera, possessing moderate resolution capabilities. It was in an ideal position for the flyby, yet no images have been released, no press statements issued, and a complete radio silence prevails. The UAE's Hope orbiter was equipped with the Emirates Exploration Imager, specifically designed for capturing detailed atmospheric and surface imagery. It too was positioned for observation, and it too remains silent. Multiple space agencies, multiple sovereign governments, disparate bureaucratic structures, distinct priorities, and separate political systems have all, concurrently, been unable or unwilling to release their highest resolution observations of the most scientifically significant object to visit our solar system in years. The pattern is difficult to ignore. Coordinated silence is not achieved by accident. Silence is coordinated when everyone witnesses the same phenomenon, and no one yet possesses a satisfactory explanation. Chapter 4: What Amateur Astronomers Observed. While the official agencies remained reticent, backyard astronomers began sharing their own observations. On the 3rd of October, the same day as the Mars flyby, a Portuguese amateur astronomer operating under the username Dobsonian Power uploaded an image to Reddit that quickly went viral. He had been tracking 3i Atlas using a solar telescope, which is not the ideal equipment for faint deep space objects, but it can be serviceable with aggressive digital enhancement. The image revealed something unexpected within the diffused glow of 3i Atlas's coma. Apparent angular structures, dark geometric shapes, and protrusions emerged, inconsistent with the typical symmetrical diffusion of a comet's dust cloud. His caption was straightforward: "What on earth is it?" Within 6 hours, the post had been shared across all major astronomy forums and subreddits. The reactions immediately divided into 2 camps. One group perceived clear evidence of artificial structures, substantiating claims that 3i Atlas was not what mainstream science purported it to be. Some suggested a cylindrical craft, while others proposed a tumbling asteroid exhibiting manufactured features. A few even posited that this represented reconnaissance technology, or perhaps a warning beacon. The other group dismissed it as a classic instance of pareidolia, the human propensity to perceive patterns in random visual stimuli, exacerbated by inappropriate equipment and aggressive image processing. Solar telescopes employ specialized filters designed to observe the sun's extreme brightness. Using such an instrument to observe a faint comet millions of kilometers away is akin to using a welder's mask as binoculars. The equipment is being asked to perform a function for which it was fundamentally not designed. Introduce aggressive digital enhancement to compensate for this inadequate setup, and one is essentially asking an algorithm to fabricate details that are not present. Herein lies the fascinating turn of events. Dobsonian Power is not some anonymous internet purveyor of conspiracy theories. His YouTube channel has documented legitimate astrophotography for over a decade, featuring detailed equipment lists, meticulous methodologies, and step-by-step explanations of image processing workflows. He possesses a thorough understanding of his craft and its limitations. When pressed about the anomalous structures, he did not rigidly defend his initial findings. He acknowledged the inherent uncertainty and promised to conduct further observations once 3I Atlas emerged from behind the Sun in December. His response was measured, scientific, and appropriately cautious. This makes the immediate coordinated debunking campaign all the more suspicious. Within 24 hours, multiple astronomy news websites published articles specifically addressing his image, with headlines such as "Amateur Telescope Captures Strange 3I Atlas Image. Here's why it's not what it seems." The timing felt deliberate, and the tone defensive, as if there was an urgent need to establish that nothing unusual had been photographed before the image gained significant traction. Subsequently, the enhancement wars commenced. Users across Reddit, Twitter, and various forums began downloading the original ESA images and subjecting them to their own processing algorithms. Some employed standard astronomical stacking techniques. Others utilized AI upscaling tools designed for enhancing low-resolution photographs. A few even resorted to complex machine learning models trained to reconstruct details from limited data. The outcomes varied considerably. Some produced nothing more than slightly sharper versions of the same faint dot. Others revealed distinct geometric patterns, defined edges, and structures that appeared too regular to be natural ice and rock. The inherent problem is that once aggressive image processing is applied, particularly with AI tools, one is no longer observing what genuinely exists. Instead, one is viewing what an algorithm perceives should be present, based on its training data. If an AI is trained on thousands of spacecraft images and then asked to enhance a blurry celestial object, it may very well generate spacecraft-like details because that is what it has learned to recognize. This represents a scientific dead end cloaked in the illusion of clarity. However, the proliferation of these enhanced images had an unintended consequence. They thoroughly obfuscated the issue, making it nearly impossible to differentiate between legitimate observations and outright fabrications. Within 48 hours of the ESA photo release, dozens of supposedly enhanced versions were circulating online. Some depicted metallic surfaces, others showed what appeared to be solar panels, antennae, and thruster arrays. A few even included running lights. The majority were obviously fabricated, digital art created by individuals with ample time and advanced Photoshop skills. Yet, amidst this deluge of misinformation, a handful of images emerged that felt different, more subtle, less sensational, displaying just enough unusual regularity to prompt contemplation about whether something real was being obscured by the flood of obvious hoaxes. And while public attention was consumed by debates over image processing techniques, a more pertinent question remained largely unaddressed. Why did an amateur, utilizing suboptimal equipment, capture an image that seemed to unsettle professional astronomers enough to initiate immediate debunking campaigns, while those same professionals, equipped with superior technology, are withholding their findings? Chapter 5. The Persistent Leak. On the 4th of October, an anonymous post appeared on 4chan's paranormal board. The title was concise: ESA Data Leak. The post began with a claim of credentials sufficiently specific to appear credible, yet vague enough to maintain anonymity. It stated, "I am a doctoral researcher working with the European Space Agency, possessing continuous access to the combined observational data of 3I Atlas." Internet leaks are a common occurrence, and most are readily dismissed as imaginative fiction or deliberate trolling. However, this particular leak was distinct. The technical depth of the information provided was unsettling. The poster did not make outlandish claims about alien invasions or describe glowing spacecraft or mysterious transmissions. Instead, they detailed a series of specific observational anomalies that, if accurate, would fundamentally alter our understanding of what 3I Atlas truly is. The first anomaly cited was chemical impossibility. According to the Post, spectroscopic analysis indicated that 3I Atlas was releasing approximately 100 kilograms of nickel gas per second, but with virtually no iron emission. In standard stellar and planetary chemistry, nickel and iron are inseparable companions. They are found together in comets and asteroids. Discovering abundant nickel with virtually no iron is akin to finding smoke without fire. It contradicts fundamental assumptions about how matter behaves in natural cosmic environments. We're now aware through published VLT observations that the nickel emission is indeed real. The Post accurately identified this aspect. What remains uncertain is whether the absence of iron is a measurement error or a genuine anomaly. The second anomaly mentioned was the thermal contradiction. The object is expelling vast quantities of gas and dust, the characteristic signature of an active comet being heated by the sun. However, infrared observations indicate that it remains cold, despite its level of outgassing and its proximity to solar radiation. The initial report drew an analogy to witnessing someone perspiring heavily within a frozen environment, highlighting a fundamental disconnect between the observed phenomena and the expected physical principles. It was noted that subsequent scholarly articles had indeed acknowledged this peculiar thermal discrepancy, confirming that the online discourse was based on actual collected data. The subsequent point of contention, the third anomaly, pertained to the extraordinary precision of the object's trajectory. The Post referenced prior public statements made by Avi Loeb, who had observed that 3 interstellar objects designated Oumuamua arrived with an orbital inclination of merely 4.89 degrees relative to Earth's ecliptic plane. However, the anonymous contributor on 4chan elaborated on this, introducing an element that Loeb had not heavily emphasized. The trajectory was not merely atypical, it represented a perfectly direct path originating from the direction of the galactic core. This path exhibited no deviation, no wavering, and no indication of gravitational influence from neighbouring stars during its multi-million or multi-billion-year journey through the void of interstellar space, as if it had been deliberately aimed. The narrative then progressed to a segment that transformed the discussion from mere intriguing speculation into something far more unsettling. The Post posited that the object's characteristics aligned with what they termed a post-biological entity, neither a naturally occurring celestial body like a comet nor a conventional spacecraft, but something existing in an intermediate state. This entity was described as possessing a 3-phase particle engine, estimated to continuously output 75 megawatts of power while transmitting an active signal, which in the words of the Post, was probing our solar system. The report concluded by presenting a theoretical framework, suggesting that Oumuamua might be a macroscopic quantum object, specifically a hypothetical construct known as a cue ball. This is an exotic theoretical entity derived from particle physics, classified as a non-topological soliton, which could theoretically manifest at scales vastly exceeding those of subatomic particles. If stable, such a cue ball could exhibit properties that defy conventional physics. It could possess immense density while appearing dispersed, capable of absorbing and instantaneously redistributing energy across its entire structure, thereby accounting for the thermal inconsistencies. Furthermore, it could potentially explain the anomalous presence of nickel, without a corresponding iron signature, if the cue ball's internal quantum state favoured the production of specific isotopes. Within a time frame of 18 hours, this detailed post was disseminated widely, captured in screenshots and shared across platforms like Reddit, Twitter, and specialised forums dedicated to UFO research. A discussion thread on the conspiracy subreddit garnered over 2,000 comments before moderators intervened, deeming it a violation of rules against unsubstantiated claims. However, the closure of this thread did not halt the discourse. Instead, it led to its fragmentation into numerous parallel conversations, each diverging in its interpretation of the original post. Some focused on the chemical anomalies, while others concentrated on the cue ball hypothesis. A select few began to draw connections to earlier assertions that Oumuamua might be the origin of the 1977 WOW signal. What renders this particular leak significant is its accuracy regarding the observed chemical composition. The detection of nickel was indeed confirmed. The thermal anomaly has been formally documented. The alignment of the trajectory presents a statistically improbable scenario. Consequently, this disclosure is either an exceptionally well-researched piece of speculative fiction or the work of an individual with access to undisclosed data who felt compelled to inform the public about observations being made by space agencies but deliberately withheld. The post-biological entity classification and the cue ball hypothesis are indeed on the fringes of scientific understanding. The descriptions of the post-biological entity evoke speculative xenobiology. Nevertheless, the underlying observational data supporting these interpretations is factual, and herein lies the disquieting aspect. When unsubstantiated theories align with factual data, it becomes increasingly difficult to dismiss the interpretations derived from that data. Chapter 6 delves into the 50,000-kilometre question. On the 4th day of October, an event occurred in the Martian sky that defied conventional understanding. NASA's Perseverance rover, situated in Jezero crater on the Martian surface, captured an image using its right navigation camera. The raw image revealed an elongated streak of light, approximately 4 times longer than its width, traversing the star-studded background. Initially, it resembled a typical long-exposure photograph of a moving celestial object. Comets and asteroids often appear smeared in images when the camera is calibrated to track stars rather than the object itself. This is standard practice. However, the situation shifted dramatically when individuals began calculating the apparent size of the object based on Perseverance's known camera specifications and Oumuamua's distance at that particular time. The resulting figure was a staggering 50,000 kilometers in length. This dimension far exceeds that of a cometary nucleus, or even a comet accompanied by a tail. It suggested something entirely different. For context, the diameter of Earth is less than 13,000 kilometers. If this streak represented the actual physical dimensions of Oumuamua, humanity was observing an object nearly 4 times the width of our entire planet. Social media platforms instantly erupted. Was Oumuamua, in reality, a colossal cylindrical craft? Had it been concealing its true size and form behind a nebulous shroud of gas and dust? The timing appeared to be of considerable importance, as this image surfaced merely 1 day following the Mars flyby, precisely when professional space agencies had fallen conspicuously silent. The ensuing speculation escalated to such a degree that Representative Anna Paulina Luna, a member of Congress known for her keen interest in unexplained aerial phenomena, directly contacted Avi Loeb for an analytical assessment. Consider this for a moment. A sitting member of the United States House of Representatives felt it imperative to reach out to a Harvard physicist regarding a photograph originating from Mars. This deviates significantly from standard protocol, implying that individuals within official capacities were sufficiently concerned to seek expert interpretation outside the customary NASA communication channels. Loeb's response was both comprehensive and, on the surface, reassuring. He calculated that Perseverance's navigation camera possesses an angular resolution of 0.33 milliradians per pixel at the distance of Oumuamua when the image was captured, approximately 38 million kilometers. This equates to roughly 12,500 kilometers per pixel. The streak in the image spanned approximately 4 pixels, thus accounting for the observed 50,000 kilometer length. However, Loeb posited that this was an artifact of composite imaging. The streak, he argued, did not depict the actual size of Oumuamua, but rather the path the object traversed across the Martian sky during a prolonged integration period, likely around 10 minutes of accumulated exposures. His reasoning was sound. Mars orbits the Sun at a velocity of 24 kilometers per second. Oumuamua was traveling at 67 kilometers per second, relative to the Sun in the opposite direction. resulting in a relative velocity of over 90 kilometers per second compared to Mars over a 10-minute interval. This translates precisely to a travel distance of 54,000 kilometers, perfectly matching the observed streak length. The elongated shape, therefore, was not indicative of the object's form, but rather its motion smeared across time. Case closed, it seemed. The cylindrical craft theory debunked by fundamental physics and meticulous calculation. However, Loeb included a single sentence in his analysis that became a focal point for conspiracy theorists, acting as a lifeline. He wrote, "If the navigation camera images represent single snapshots with an exposure time below 3.28 seconds, then the brightness and angular length of the observed source imply that it is not Oumuamua. In that case, the source might be much closer to the camera, capable of being smeared into an elongated image with a smaller spatial size and a smaller speed." This statement introduced a critical ambiguity. If these were single-frame captures, then what Perseverance had photographed was not Oumuamua at all, but something else entirely, something in much closer proximity to Mars. This qualifier opened a door that subsequent clarifications could not fully shut. NASA has not confirmed whether the image is a composite or a single frame, nor has it released the associated metadata, including exposure time or the number of stacked images. The excuse of a government shutdown was also cited, implying a lack of personnel to process requests and confirm basic technical details regarding image acquisition. Consequently, two possibilities remain. Either Perseverance captured a 10-minute time-lapse of Oumuamua traversing 50,000 kilometers of space, which appears as a streak due to motion blur, or Perseverance recorded something closer, moving at a slower pace, which created a similar apparent length through different mechanisms. The mathematical calculations support both scenarios, and the observational data is consistent with either interpretation. Without the metadata, a definitive conclusion cannot be reached. The prolonged absence of this metadata fuels speculation, leading many to wonder if there is a deliberate reason for withholding information about how the image was produced. Chapter 7 addresses 48 years of silence. On the 15th day of August, 1977, Ohio State University's Big Ear Radio Telescope was engaged in its routine celestial survey, actively searching for indications of extraterrestrial intelligence. At 10:16 p.m. Eastern Time, the telescope detected a radio energy burst lasting 72 seconds. The signal was so unusual and so perfectly structured that astronomer Jerry Eman circled it on the printout, annotating it with a single word in red ink. Wow. For nearly 5 decades, this signal has remained one of the most profound enigmas in the quest for extraterrestrial intelligence. It originated from the direction of Sagittarius, near the constellation's most densely populated starfields. The signal was narrow-band, focused on a single specific frequency, and has never been repeated. Hundreds of subsequent observational attempts, spanning thousands of hours of listening time directed at the same region of the sky, yielded nothing. Only that singular burst, 48 years prior, followed by an enduring silence, until Avi Loeb performed calculations concerning Oumuamua. He determined the object's location on August 12, 1977, a mere 3 days before the WOW signal was detected. Its position was approximately 600 astronomical units from Earth, roughly 600 times the distance between the Earth and the Sun. This placed it within the outer reaches of our solar system, albeit far beyond the extent of any human-made spacecraft. More critically, Loeb calculated the direction from which Oumuamua was approaching at that time, a right ascension of 19 hours 40 minutes and a declination of plus 19 degrees. The WOW signal, conversely, came from a right ascension of 19 hours 25 minutes and a declination of minus 27 degrees. These two directions are separated by approximately 9 degrees. In the immense expanse of space, with celestial objects originating from literally any conceivable direction, the probability of such an alignment occurring randomly is estimated to be around 0.6%. While not impossible, This coincidence is profoundly suspicious. Loeb did not cease his investigation at this point. He proceeded to ask the subsequent logical question. If Oumuamua transmitted the WOW signal from a distance of 600 astronomical units, what would be the required power output of the transmitter? The mathematical computation is straightforward. The detected intensity ranged between 54 and 212 Jansky across a 10 kHz bandwidth at a distance of 600 AU. This corresponds to a transmitter output between half a gigawatt and 2 gigawatts. For comparison, a typical nuclear reactor on Earth generates approximately 1 gigawatt. Therefore, we are discussing energy levels comparable to those of a nuclear power plant, focused into a narrow radio beam. This is not beyond the realm of possibility for an advanced civilization. In fact, it is quite reasonable if the objective is to transmit a detectable signal across interstellar distances without expending energy on omnidirectional broadcasting. An additional detail further complicates the dismissal of this connection. The WOW signal was observed at a frequency of 1,420.4556 MHz, blue shifted by approximately 10 km per second toward Earth relative to the hydrogen line. This blue shift indicates that the source was moving towards us. Oumuamua is currently approaching the Sun at approximately 60 km per second. Loeb suggests that if this object possesses maneuvering capabilities, it might have been travelling at a slower velocity in 1977 and subsequently accelerated after detecting planets within the habitable zone of our solar system. This could be interpreted as a reconnaissance pulse, a radar scan to ascertain the presence of technological civilizations before committing to a closer approach. What makes this entire correlation so vexing is that it could be trivially verified. Simply point a radio telescope at Oumuamua and listen at the hydrogen line frequency. If it is transmitting, we would know within hours. If it remains silent, the connection to the WOW signal is likely coincidental. This represents a simple test with a definitive outcome. Yet, as Loeb noted in his most recent blog post, not a single radio telescope has reported data concerning Oumuamua. The Very Large Array has not conducted observations, the Arecibo telescope is no longer operational, and the Green Bank telescope has not published any findings. Even SETI, the organisation whose very mission is to detect extraterrestrial signals, has not publicly announced any monitoring efforts. The silence emanating from the radio astronomy community is deafening. Some contend that Oumuamua is too faint, too distant, and too deeply obscured by the background noise of the galactic plane to yield useful radio data. They argue that telescope time is a precious resource and should be allocated to more promising targets. Others point out that if there is a 0.6% probability of confirming that the most celebrated unidentified radio signal in human history originated from an object currently within our solar system, one might reasonably expect that this would warrant a few hours of observational time. The fact that no public attempt at such an observation has been made, or at least no results have been published, raises questions about the private discussions taking place, the existence of undisclosed data, and the observations that have been made but not publicly acknowledged. Because if an individual were to direct a telescope at Oumuamua and detect a signal at 1,420 MHz, what would be their course of action? Immediate publication would be the logical step, followed by verification through multiple independent observations. The first course of action would likely involve contacting government agencies for guidance on how to announce the detection of an active transmission from an interstellar object. The scientific method dictates, publish everything. Transparency demands immediate disclosure. However, the social and political ramifications of confirming extraterrestrial technology within our solar system are so profound that even scientists might hesitate before submitting a paper detailing such a discovery. And in that hesitation, in the interval between observation and publication, silence itself becomes a form of data. Chapter 8 addresses the path that shouldn't exist. Envision the act of throwing a dart at a globe from across a room while blindfolded. Now, Imagine that dart not only strikes the globe but lands within a few degrees of the equator. This approximates the statistical improbability we are confronting when examining Oumuamua's entry into our solar system. Objects originating from interstellar space can arrive from literally any direction. They ought to be randomly distributed across the celestial sphere, approaching at all possible angles. The galaxy is a three-dimensional entity. Stars orbit the galactic center in every orientation. Objects ejected from other star systems possess no preferential alignment with the plane of our solar system. Yet, Oumuamua arrived with an orbital inclination of a mere 4.89 degrees relative to Earth's ecliptic plane, less than 5 degrees. This places it within less than 1% of all possible arrival angles. Avi Loeb has been relentlessly emphasizing this point in every interview, every blog post and every public statement since July. The trajectory is not merely unusual or rare, it is statistically profoundly unlikely for a random interstellar object. To grasp why this is the case, one must consider the dynamics of objects moving through the galaxy. Stars in the Milky Way disk orbit the galactic center with a certain average velocity. However, they also exhibit random motions both vertically and laterally, akin to bees swarming around a hive. This inherent randomness implies that objects ejected from other star systems should arrive at our solar system from all directions with roughly equal probability. There is no favoured direction, no cosmic superhighway funneling interstellar visitors into our ecliptic plane. And before anyone suggests that objects from the Milky Way disk might naturally arrive at shallow angles, Loeb has addressed this as well. The galactic disk itself is tilted approximately 60 degrees relative to the ecliptic plane of our solar system. 60 degrees, that is more than 10 times the inclination of Oumuamua. If this object originated from a typical star system within the galactic disk and was ejected randomly, we would expect it to arrive at a steep angle, not a shallow one. This alignment is contrary to what galactic geometry would predict. Compare Oumuamua to the only other interstellar objects we have detected. Oumuamua, discovered in 2017, arrived with an inclination of 123 degrees, arriving at a steep angle from above the solar system plane. 2 I Borisov, spotted in 2019, had an inclination of 44 degrees, still steep and consistent with a random arrival from interstellar space. Both of those objects behave precisely as expected for natural interstellar visitors. Oumuamua stands as the outlier, the anomaly, the one that deviates from the established pattern. Loeb calculated the probability of this alignment, assuming random directions at less than 1%. Some colleagues have pushed back, suggesting that his statistical analysis might be overly conservative, and the actual probability could be closer to 5 or 10% when accounting for various selection effects and observational biases. Even if we accept a 10% probability, it still suggests an event that should occur only once in every 10 interstellar objects we detect, and we have only detected 3. The odds of the third object being the rare exception rather than the rule are not in favour of coincidence. Now, layer this upon everything else. The WOW signal alignment, also with less than 1% probability. The chemical anomalies with nickel but no iron. The thermal paradoxes. The absence of high-resolution imagery from multiple space agencies. The government shutdown occurring precisely when NASA's capabilities are most needed. Any single one of these occurrences could be rationalized away as coincidence, measurement error, or bureaucratic incompetence. However, when anomalies begin to accumulate, when small probabilities are multiplied together, the compounded improbability becomes increasingly difficult to dismiss. There is a principle in statistics known as the prosecutor's fallacy. It is the error of treating multiple independent low-probability events as if they are related, when in reality they are merely random coincidences that happen to cluster together. If you flip a coin enough times, you will eventually achieve 10 consecutive heads. This does not imply the coin is rigged. It simply means you have flipped it sufficiently often for unlikely sequences to occur. skeptics will argue that this is precisely what we are witnessing with Oumuamua, a natural comet possessing several unusual but ultimately explainable characteristics that coincidentally manifested together in the same object. Unlikely, certainly, but not impossible. The counter-argument is equally valid. If an object exhibits the characteristics of a duck, it walks like a duck, quacks like a duck, swims like a duck, and possesses duck DNA. At some point, one must consider the possibility that it is in fact a duck. Or, in this case, if an object arrives on a statistically improbable trajectory, displays chemical signatures inconsistent with natural processes, correlates with a 48-year-old unexplained radio signal, and prompts multiple governments to withhold their most advanced imaging data, perhaps it is worth seriously considering that we're not observing a random fragment of ice and rock from another star system. Chapter 9 discusses when questions become dangerous. Around October 5th, something peculiar began to occur. Users across various platforms started reporting that their posts concerning Oumuamua were disappearing. These posts were not being flagged or labelled as misinformation. They were, in effect, vanishing. A Reddit user documented the experience of posting a detailed thread analysing the chemical anomalies derived from the alleged Issa leak. The thread gained considerable traction, accumulating hundreds of upvotes and dozens of comments within 2 hours. Subsequently, it was gone, not removed with an explanation from moderators, but simply erased from existence. When the user attempted to repost it, the submission failed to go through. On X, formerly Twitter, several accounts reported similar patterns of shadow banning without notification or explanation. The account Astronomy Vibes, which had achieved viral status for its criticism of Issa photographs, reported a significant decline in engagement after October 7th. Posts that would normally reach tens of thousands of individuals were suddenly plateauing at a few hundred views. There were no official restrictions or warning messages, only algorithmic suppression, subtle enough to be deniable, yet aggressive enough to be effective. Other content creators in the space astronomy community observed the same phenomenon. Videos discussing Oumuamua, which typically performed well, were reaching only a fraction of their usual audience. YouTube presented a different challenge. Content creators who posted analytical videos speculating about Oumuamua began receiving demonetization notices, with the stated reasons varying. Certain content faced restrictions due to discussions of sensitive subjects lacking adequate context. Other submissions were categorized as potentially deceptive regarding scientific subjects. A select few received the ambiguous yet concerning designation of content unsuitable for advertiser endorsement. The underlying pattern was evident. One could produce a video asserting with certainty that 3 Atlas was merely a comet, and that established science had fully explained it. Such content was permissible, earning revenue and promoted. However, suggesting the existence of anomalies warranting investigation would suddenly render a video unwelcome by advertisers. Facebook's methodology was the most overt. The platform's system for verifying facts, managed by independent auditing groups, began rigorously flagging information pertaining to 3 Atlas. Posts circulating the 4chan leak were tagged with warnings about missing context. Assertions regarding trajectory anomalies were deemed partially inaccurate, even when the posts merely reproduced Avi's published calculations verbatim. The accompanying fact-checking articles aimed to provide reassurance. Official space organizations affirmed that no peril emanated from the interstellar visitor. Experts indicated that peculiar features were likely natural occurrences. The unspoken message was clear: refrain from concern, avoid speculation, and place your trust in authoritative sources. Proceed as usual. The timing appeared deliberate. All these actions intensified within 48 hours of the Issa image release, precisely when public dissatisfaction regarding the absence of high-quality imagery was at its peak. This type of occurrence can make those prone to conspiracy theories feel validated and cause skeptics to dismiss it as excessive paranoia. The reality is that social media platforms frequently restrict content. Algorithmic adjustments are commonplace. Engagement levels fluctuate. Fact-checkers identify and flag misinformation. These are standard operational procedures for these platforms, not indicators of a concerted effort at censorship. This holds true unless a discernible pattern emerges if everything happens concurrently, targeting a specific subject at the very moment public interest is highest, and official explanations are most lacking. Some content creators began employing coded language to circumvent these restrictions. Instead of referring to 3 Atlas, they would use terms like the visitor or the object. In place of alien or extraterrestrial, they opted for non-terrestrial or anomalous. It was akin to witnessing the development of a new lexicon for discussing a subject that the platforms preferred to keep out of open discourse. This was the Streisand effect in real time. The more content was suppressed, the more people suspected something valuable was being concealed. The more vehemently fact-checkers refuted claims, the less trust people placed in the official account. Every attempt to control the narrative only amplified the suspicion that the narrative indeed required management. Chapter 10. The Moment We Cannot Witness. Mark October 29th and 30th as pivotal dates. As you listen to this, 3 Atlas is less than 10 days from its closest approach, set for a Sunday. It will pass at a distance of approximately 22 million kilometers, just inside the orbital path of Mars. For a naturally occurring comet, this is the critical juncture. The intense solar radiation at this proximity should induce significant outgassing, potentially even fragmentation. We've observed this phenomenon before. Comets approach the Sun, the heat becomes overwhelming, and they disintegrate into multiple pieces. This is a spectacular event when it occurs. If 3 Atlas is simply an ordinary collection of ice and rock originating from another star system, this is precisely what is anticipated. However, here lies the predicament. We will be unable to observe it. 3 Atlas will be positioned on the opposite side of the Sun from Earth during its perihelion passage. Every terrestrial telescope will be rendered useless. The object will be obscured by the Sun's glare, completely hidden from observation during what should be its most active and revealing phase. Some are terming this an unfortunate coincidence. Others perceive it as suspiciously opportune. If one intended to undertake an action undetected, a more advantageous time frame could not be chosen. Avi Lowe has been explicit regarding subsequent events. In his blog post dated October 3rd, published on the day of the Mars flyby, he outlined 2 potential scenarios. If 3 Atlas is a natural comet, it might soon erupt with a burst of outgassing or fracture into icy debris. The Sun's rays will impart gigawatts of energy onto its surface. This energy must dissipate. For ice and rock, this results in vaporization, sublimation, and possibly structural failure. However, Lowe then posited an alternative. Alternatively, if it possesses a technological origin, it may engage in maneuvers to leverage the Sun's gravitational assistance, or deploy probes capable of intercepting Earth or other planets, owing to its retrograde orbit, which is in the opposite direction of the planet's movement around the Sun. Reread that. Deploy probes capable of intercepting Earth. He is no longer discussing passive observation, he's referring to active deployment. The retrograde orbit is the crucial factor here. 3 Atlas is travelling in the opposite direction to the planet's orbital paths around the Sun. This means any probe it releases would not need to contend with planetary motion to reach us. It could simply enter an intercept trajectory, allowing orbital mechanics to perform the task. Emerging from behind the Sun, unseen, it would be effortless to launch an object toward Earth that would remain undetected until it was in close proximity. Lowe elaborated further, writing, "As you observe the Sun in the coming weeks, remember that 3 Atlas is passing behind it. If 3 Atlas maneuvers towards Earth upon reappearing from behind the Sun, financial markets could experience a collapse. Financial markets could experience a collapse. This is not a metaphor, it is not hyperbole." He suggests that if this object demonstrates technological capability, if it alters its course toward Earth after perihelion, the economic and societal repercussions would be immediate and severe. Stock markets react to uncertainty. The uncertainty presented by a potentially hostile interstellar object deliberately altering its trajectory towards our planet would be of existential magnitude. The confluence of these events intensifies the tension. The government shutdown means NASA is non-operational during this critical observation period. The most compelling images from the Mars flyby remain undisclosed. Amateur astronomers are unable to observe the object for the subsequent month due to its position behind the Sun. Radio telescopes have not detected any transmissions. We're navigating blindly towards the most significant moment of this entire encounter. And whether through negligence or design, we've created a situation where we will not ascertain 3 Atlas's actions at perihelion until after they have occurred. There is one group actively observing. The Galileo project, spearheaded by Lowe himself, operates 3 observatories, one in Massachusetts, one in Pennsylvania, and one in Nevada. These facilities are equipped with high-resolution cameras, infrared sensors, and radio receivers specifically designed to detect anomalous aerial phenomena. Throughout late October and early November, all 3 observatories will be functioning at their maximum capacity, monitoring the skies for any unusual activity. If 3 Atlas deploys probes, or if there is an increase in UAP activity coinciding with its perihelion passage, the Galileo instruments may capture evidence. May is the operative word. 3 observatories covering a minuscule portion of Earth's sky. If an object arrives and avoids these specific observation zones, we will miss it entirely. Chapter 11. What the Sun Conceals. Let us discuss what transpires when an object approaches a star so closely. At 136 astronomical units, approximately 203 million kilometers, the Sun's radiation intensifies. It is not sufficient to vaporize rock, but it is more than adequate to superheat any volatile compounds: water, ice, carbon dioxide, frozen methane. Any substance with a low sublimation point will transition directly from a solid to a gaseous state. For a natural comet, this phenomenon gives rise to the spectacular displays we associate with these celestial bodies. The coma expands dramatically. The tail stretches for millions of kilometers. Dust particles expelled by escaping gas catch sunlight and emit a glow. Occasionally, the nucleus fractures, forming multiple fragments, each developing its own tail. Comet Lovejoy famously disintegrated during its perihelion passage in 2013, torn apart by solar tides and thermal stress. Comet Shoemaker-Levy 9 broke into numerous pieces before impacting Jupiter in 1994. Fragmentation is a common and expected occurrence, a natural consequence of icy bodies encountering extreme conditions for which they were not designed. If 3 Atlas fragments at perihelion, this provides definitive information. Natural comets break apart. Artificial constructs do not in the same manner, not through the same mechanisms. But if it remains intact, perhaps even more active than before, what conclusions can be drawn? One possibility is that the object is larger and more structurally sound than our estimates suggest. A solid nucleus several kilometers in diameter might withstand perihelion without fragmenting, especially if composed of refractory materials, rocky substances with high melting points, rather than pure ice. Another possibility is that the object is not experiencing the thermal stress we would anticipate because it is not absorbing solar radiation in the same way natural materials do. If its surface possesses unusually high albedo, meaning high reflectivity, most of the sun's energy would be reflected rather than absorbed by the interior. Certain synthetic materials exhibit precisely this characteristic, highly reflective coatings engineered to minimize thermal load. A third possibility is that the object is regulating its own temperature, actively managing heat distribution through mechanisms yet to be identified. These would be systems designed to endure close stellar approaches without sustaining damage. The solar assist maneuver, which Lowe mentioned, warrants understanding. In orbital mechanics, trajectory modifications are most efficiently executed at the point of highest velocity. For an object approaching the Sun, this point is perihelion. A minor thrust applied at maximum speed results in the greatest alteration of orbital energy. This principle operates in both directions. It can be utilized to accelerate departure from a star system or to decelerate, thereby entering a bound orbit around a star being visited for the first time. If 3 Atlas is natural, it will continue along its hyperbolic trajectory after perihelion, eventually departing the solar system permanently. Its velocity relative to the Sun will remain approximately constant at 58 kilometers per second as it recedes into interstellar space. If 3 Atlas is technological and performs a reverse solar assist maneuver, its velocity will decrease. Not drastically, not instantaneously, but measurably enough to transition from a hyperbolic trajectory to an elliptical one, sufficient to become gravitationally bound to the Sun rather than merely passing through. The change would be subtle, perhaps a few kilometers per second, difficult to detect unless one is specifically searching for it, but it would signify that the object is not leaving, it is remaining. And if it remains, the subsequent question arises, why? Scientific curiosity does not necessitate capture. A solar system can be studied effectively during a flyby trajectory. Data is collected during the passage, transmitted back, and the probe proceeds to its next objective. This is precisely what our own interstellar probes will do when they eventually reach other star systems. Voyager 1 is already in interstellar space. It did not halt. It did not enter another star's orbit. It simply continued its journey. Therefore, if an entity chooses to remain, it is not merely observing, it is undertaking actions that require extended periods, activities that cannot be accomplished during a brief flyby, such as construction, deployment, or preparation. The fact that we are unable to observe events during this crucial phase is either a consequence of the universe's most unfortunate timing or a testament to impeccable operational planning. Chapter 12. The Images We Await. From November 2nd through the 25th, 2025, the European Space Agency's Jupiter Icy Moons Explorer, JUICE, will be observing 3 Atlas using its various instruments. This observation period will commence shortly after perihelion, when the object is expected to be at its most active. JUICE was not originally designed for comet observation. Its mission is to study Jupiter's moons Ganymede, Europa, and Callisto. However, its trajectory happens to provide a clear line of sight to 3 Atlas during a period when Earth-based observation is challenging. Someone recognized this opportune moment and adjusted the mission timeline to incorporate these observations. The spacecraft is equipped with multiple instruments, including the Janus camera for visible light imaging, the MAGIS spectrometer for infrared analysis, the SWI submillimeter instrument for detecting gas emissions, and the UVS ultraviolet spectrograph for studying the composition of the coma. If 3 Atlas is experiencing a full outburst, JUICE will capture the event. The spectral data will reveal the precise composition of the released gases. The imaging data will provide an unprecedentedly detailed view of the nucleus and coma structure. We will be able to discern the locations of fragmentation, the development of new jets, and whether the object's appearance has changed following its closest approach to the Sun. The caveat: the data will not be accessible until February 2026. This represents a 7-month delay for images captured in November. 7 months of uncertainty regarding whether the heightened activity observed by JUICE is typical cometary outgassing or something else entirely. 7 months of pondering whether the faint dot presented by ESA in October was truly the best they could provide, or if they are deliberately managing a revelation they are uncertain how to convey. Communication delays are a genuine factor. Deep space missions transmit data at slow rates. JUICE is located far from Earth, and bandwidth is limited. The raw images must be downloaded, processed, calibrated, and analyzed. Scientific teams require time to interpret their findings before making them publicly available. All of these points are valid. All of these are standard procedures. All of this explains the delay in immediate data release. However, 7 months is a considerable duration. it is sufficient time for careful consideration of how to present findings. It is ample time for coordination between agencies regarding what information to disseminate and how to articulate it. It provides governments with adequate time to prepare for public reactions should the findings be anomalous. In the interim, the object will become visible again from Earth in early December. Amateur astronomers will track its path. Professional observatories will conduct observations. We will measure its brightness, its trajectory, and its spectral signatures, but we will lack the close-up perspective. We will not possess the high-resolution data from the period of its peak activity. That critical window is currently passing while we are effectively blind, while it is obscured behind the sun, engaged in whatever activities it is undertaking. Chapter 13. What building signifies. Let us address the unspoken elephant in the room. The question, what is 3 Atlas doing to the sun, implies action, intent, and purpose. However, perhaps we are posing the incorrect question. Perhaps the question is not what 3 Atlas is doing to the sun, but rather what the sun is doing to 3 Atlas. Stars do not merely provide light and heat, they furnish essential raw materials. The solar wind, a continuous stream of charged particles emanating outward, contains ionized hydrogen, helium, trace amounts of heavier elements, free protons and electrons, the fundamental building blocks of matter in their simplest, most accessible form. If you were an interstellar probe journeying for millions of years through the vast emptiness, you would require a strategy for replenishment. You would need a method to restore what has been lost due to micrometeoroid impacts and radiation degradation. You would need raw materials for repairs, for replication, and for whatever comes next. And if you were engineered by a civilization billions of years old, one that evolved in a universe where stars are the most predictable, abundant and reliable resources available, you would naturally gravitate towards them, not out of peril, but out of utility. The leaked 4chan post mentioned a 3-phase particle engine. While speculative, the underlying concept is not unreasonable. A plasma-based propulsion system that utilizes ionized material from the solar wind as reaction mass. This would necessitate a magnetic field to collect and direct the plasma, along with a power source to accelerate it to usable velocities. The sun, however, provides the fuel at no cost. Position oneself near perihelion, allow the solar wind to envelop the craft, collect the necessary materials, process them, and store them. When ready, utilize them. This could explain the object's low temperature. Despite significant outgassing, if the object is engineered to efficiently radiate waste heat while operating near a star, it would register as cold to infrared sensors, even while internally processing enormous amounts of energy. It could account for the unusual carbon dioxide-rich emissions. If the constituent components of the solar wind are being broken down and recombined, the byproducts might not align with the chemistry of natural comets. The resulting ratios could appear impossible for icy bodies formed in protoplanetary disks. It could also explain the anomaly of detecting nickel without iron. If specific isotopes from stellar material are being selectively extracted and processed, the emission spectrum would reflect what is being utilized versus what is being discarded. The concept of building on Mars is one interpretation. However, what if it is not constructing structures? What if it is augmenting itself, undergoing repairs, refueling, or preparing for the subsequent phase of whatever mission brought it here? Or more disturbingly, what if it is not building at all? What if it is transmitting data, information, a comprehensive record of its observations during its transit through our solar system? The composition of our star, the arrangement of our planets, the presence of a technological civilization on the 3rd planet, radio emissions, light pollution, atmospheric composition indicating industrial chemistry, everything one would wish to know about a solar system before committing resources to future endeavors. Transmitting where? Back to its point of origin. Assuming faster-than-light communication is not employed, that signal would take thousands or millions of years to reach its destination, depending on the distance 3 Atlas has travelled to arrive here. But if one belongs to a civilization that contemplates in geological timescales, if probes have been seeded throughout the galaxy over billions of years, then patience is a virtue. One can afford to wait, because once the signal is received, once the analysis is complete, and once a decision is rendered regarding whether this system warrants a personal visit or the dispatch of more sophisticated hardware, the response will already be in transit, having departed however long it takes light to traverse the distance between here and there. Perhaps 3 Atlas is not the initial probe. Perhaps it is a scout, and somewhere behind it, moving at a slower pace but possessing greater capabilities, another entity is approaching. It may not arrive for centuries, perhaps millennia, but it is on its way. And if this scenario is accurate, if this is what we are truly observing, then the question is not what it is doing to the sun. The question is, what will happen when they receive the message? Chapter 14. The Silence of the Stars. There exists a concept in astrobiology known as the Great Filter. It proposes that somewhere between the emergence of life and the development of galaxy-spanning civilizations, there lies a barrier, a filter that most species fail to surmount. This barrier could be the transition from single-celled to multicellular life, the development of intelligence, or the shift from a planetary to an interplanetary civilization. Alternatively, it could be something yet to be encountered, a challenge that lies ahead. The filter might be behind us, meaning we're among the rare species that have successfully navigated the most difficult stages. In this case, the galaxy should be ours to explore, empty and awaiting, replete with resources and territory, with no competition. Conversely, the filter could be in our future, representing an obstacle we have not yet faced, a test we have not yet failed simply because we have not reached that stage. In this scenario, the galaxy's silence is not indicative of our solitude, but rather of the fact that all other civilizations that have reached this point have succumbed to whatever lies ahead. The dark forest hypothesis extends this concept further. It posits that the galaxy is not empty, but teeming with life. However, all entities are in hiding because the fundamental rule of survival in a universe with finite resources and unknown neighbors is to conceal one's location and remain silent. Transmit only text, no instructions or comments. Be discreet. Never reveal your location to potential rivals or predators until you are absolutely certain you can handle any emergent threats. Within this desolate cosmic expanse, every society functions as both hunter and hunted. You move with absolute quietude, constantly vigilant for any signs of others. Upon encountering another entity, a critical decision must be made before they make one about you. Arvlo's academic work, which posited that the object known as 3i Atlas might be artificial, explicitly incorporated this principle. This was not founded on a belief in the veracity of the dark forest hypothesis, but rather on the premise that if it were true, and if 3i Atlas were indeed a manufactured entity, we would need to carefully consider the implications for our own defensive strategies. If it is a reconnaissance device, we are under observation and undergoing evaluation. Every action we take, every signal we transmit, every decision we make regarding our response to its presence, all of it constitutes data. All of it is meticulously recorded, analysed and relayed back to its origin. In such a scenario, our reaction assumes paramount importance. Our response becomes an integral part of the assessment. How will we manage our initial encounter with technology originating from another star? Will we succumb to panic? Will we resort to aggression? Will we attempt to establish communication? Or will we simply ignore it, hoping it will depart? Each choice will illuminate facets of our species' nature, the level of our technological advancement, and whether we are deemed worthy of interaction or are simply too undeveloped, too belligerent, or too unstable. The very fact that governing bodies are withholding information could itself be significant. It might indicate a preparedness deficit, suggesting that those tasked with managing potential first contact situations have reviewed human history, specifically our past interactions with civilizations possessing vastly different technological capabilities, and concluded that complete transparency would inflict more harm than a calculated silence. Alternatively, it might imply the precise opposite, that the entities withholding data are buying time, not to manage public apprehension, but to devise a strategic countermeasure, ensuring that by the time the full narrative is revealed and its ramifications become evident, we will be as prepared as possible for whatever lies ahead. Chapter 15. What follows the early days of November? That is the period when the Three-Eye Atlas is scheduled to re-emerge from behind the Sun, once again becoming visible from Earth. Terrestrial telescopes will meticulously track its progress. We will meticulously measure its luminosity, its orbital path, and its spectral signature. We will ascertain whether it successfully navigated perihelion intact, or if it fractured under the immense solar forces. We will determine if any adjustments to its course have occurred, and ultimately, we will discover whether the past 4 months of speculation, the proliferation of conspiracy theories, and the lingering unanswered questions were warranted, or merely the product of widespread hysteria concerning a wholly natural interstellar visitor. If the Three-Eye Atlas reappears on the same trajectory with which it entered our solar system, if it displays clear evidence of fragmentation or enhanced outgassing consistent with solar heating, and if its behavior mirrors that of Two-Eye divided by Borisov during its solar approach in 2019, then the enigma will be essentially resolved. It will be identified as a natural comet, its peculiar chemical composition notwithstanding, and its statistically improbable trajectory acknowledged. It will ultimately be classified as nothing more than an icy remnant from another star system passing through ours. The connection to the WOW signal will then be dismissed as mere coincidence. The alleged leak from 4chan will be relegated to the realm of imaginative fiction. The missing images from NASA will be explained as administrative delays during a governmental shutdown. The suppression of content on social media platforms will be attributed to overly zealous moderation policies. Everything will align within the established framework where interstellar objects are intriguing but not alarming phenomena. However, should its re-emergence deviate from this pattern, if the Three-Eye Atlas reappears with an altered trajectory, if it exhibits even minor course corrections inexplicable by outgassing propulsion, if radio telescopes finally focus on it and detect structured transmissions, and if the NASA images are eventually released and reveal geometric formations inconsistent with natural celestial bodies, then we will be venturing into entirely uncharted territory. This will extend beyond the scientific realm, impacting society, politics, and economics. Every fundamental assumption about our place within the cosmos will be challenged. The response of every government to the prospect of extraterrestrial contact will be tested in real time. R.V. Lowe developed a system he terms the Lowe scale. This is a classification method to gauge the likelihood of an object being of artificial origin and the degree of potential threat it presents. A rank of 1 signifies it is almost certainly natural, exhibiting interesting but explicable anomalies. A rank of 10 indicates it is definitively artificial, demonstrating hostile intent and the capacity to reach Earth. He publicly stated that he would not assign the Three-Eye Atlas a rank lower than a 2. Even in the most favourable interpretation, the anomalies are too persistent, too numerous, and too correlated. A rank of 2 signifies it is probably natural, but with sufficient unexplained characteristics to warrant thorough investigation. It means that we cannot definitively exclude an artificial origin without further data. This is our current predicament. We are in a state of suspension, caught between the possibility of a natural object and a potential technological artifact. We are awaiting November. We are awaiting the high-resolution images that may never materialize. We are awaiting radio observations that have yet to occur. We are waiting for the Three-Eye Atlas to either continue on its hyperbolic trajectory out of our solar system, never to be seen again, or to perform an action that compels us to confront the reality that we are not alone, and we are inadequately prepared. Chapter 16. The Unspoken Question. Throughout this entire examination, we have been operating under an assumption that may be fundamentally flawed. We have been posing the questions: what is the 3i Atlas? Is it a natural phenomenon or an artificial construct? Is it a comet or a probe? Is it dangerous or benign? But perhaps the more crucial question is, what does it desire? If it is a natural object, it has no desires. Comets do not possess intentions. They are governed by the immutable laws of physics, gravity, and thermodynamics, the principles that dictate the behavior of icy bodies within stellar environments. However, if it is artificial, if there exists even a 5% probability that it represents technology from another star, then its intentions become paramount. Its purpose becomes significant. Understanding the rationale behind its presence is more critical than comprehending its material composition. Why would one dispatch a probe to another star system? What justifies the immense expenditure of resources, the centuries or millennia of transit time, and the inherent risks of technological failure or destruction during the voyage? Purposes could include surveying and cataloguing, mapping the distribution of star systems, planetary configurations, and the prevalence of life and intelligence throughout the galaxy. This would be pure scientific endeavour, lacking immediate practical application, but invaluable for understanding the universe one inhabits. Another purpose could be resource assessment, identifying systems containing valuable materials, rare elements, or energy-rich configurations, and designating them for future exploitation. This would be relevant when preparing to expand beyond one's home system. Biosignature monitoring is also a possibility, tracking the evolutionary development of life across millions of planets simultaneously. Observing the frequency with which simple chemistry gives rise to complexity, how often complexity leads to intelligence, and how frequently intelligence develops into technology capable of long-term survival, or something more sinister. Threat assessment is another critical function, an early warning system designed to identify emerging technological civilizations while they are still confined to a single planet, thus remaining vulnerable and too primitive to defend themselves against an entity that has had a million-year head start. If one subscribes to the dark forest hypothesis, this final option is not a manifestation of paranoia. It is a survival imperative. One observes, one evaluates, and one acts before a potential threat escalates into a tangible problem. The close approaches of the 3i Atlas to Venus, Mars, and Jupiter are not random occurrences. The precision of its trajectory, which brings it in proximity to all three planets with a cumulative probability of 0.005%, cannot be attributed to chance. If it is artificial, these close approaches are deliberate. They serve as data collection points, optimal positions for detailed observation of each world's atmosphere, magnetic field, and geological activity. Earth does not warrant a close approach because Earth is not in need of one. We have been broadcasting our presence for a century. Radio, television, radar, every communication satellite, every terrestrial transmitter, every military installation utilizing active radar. All of it has been leaking into space, generating an electromagnetic signature discernible from light years away. We have already unequivocally informed any potential listeners of our precise location and our technological capabilities. A close flyby would be superfluous. However, Mars, Venus, and Jupiter do not broadcast their presence. They necessitate direct observation. Close passes with sensitive instruments are required to ascertain atmospheric composition, search for biosignatures, and evaluate resource availability. If the 3i Atlas is currently gathering this data behind the Sun, rendering it invisible to us, then the question is not what it is doing to the Sun, but rather, what report is it transmitting home? What assessment is it formulating about this solar system and about us? And what will be the consequences when that report arrives? Chapter 17. The Burden of Knowledge. Science fiction frequently depicts a singular moment of discovery, the instant humanity realizes it is not alone. This revelation is typically portrayed as a transformative, unifying event, rendering the petty conflicts and divisions that define human civilization seemingly insignificant and meaningless against the backdrop of cosmic perspective. The reality, however, would likely be considerably more chaotic. Different nations would react in divergent ways. Some would perceive opportunities, others would foresee threats. Religious institutions would grapple with profound theological implications. Financial markets would experience extreme volatility as investors attempted to assign value to completely unprecedented variables. Conspiracy theorists would feel their convictions validated. Scientists would engage in fierce debates over data interpretation. Politicians would likely exploit the situation for partisan gain. Amidst all this turmoil, the object itself would continue its activities, oblivious to our confusion. This is precisely why those managing such scenarios proceed with extreme caution. It is why data undergoes multiple review cycles before public dissemination. It is why interagency coordination occurs behind closed doors prior to any public announcements. This is not an act of concealing extraterrestrial life, but rather an effort to prevent widespread panic, economic collapse, and social instability that could be triggered by information for which the public is neither psychologically nor institutionally prepared. The absence of the NASA images might represent precisely this form of careful management. If the HiRISE telescope captured something ambiguous, something that could be interpreted as either natural or artificial, depending on one's predispositions, releasing it without context, without expert analysis, and without coordination with other agencies would be an act of irresponsibility. It would be preferable to wait, to gather more data, to reach a consensus on what the images depict and what they do not, and to prepare the groundwork for public release with accompanying educational materials explaining what people are observing and why jumping to premature conclusions would be ill-advised. This is the charitable interpretation, one that presumes competence and good intentions. The uncharitable interpretation suggests that the images reveal something so unequivocally artificial that no amount of careful contextualization could prevent the immediate conclusion that we are observing technology from another star. In such a scenario, withholding the data is not about managing public apprehension, but about controlling the narrative, dictating who receives what information and when. It is about maintaining an information imbalance between those in positions of power and the general populace. Both interpretations are plausible and consistent with the observed pattern of silence. Without access to the data, we cannot ascertain which is accurate. However, we can be certain of this. The longer this silence persists, the less trust the public will place in any eventual explanation. Every day without release, every week without disclosure, every month that passes without the images we were promised, all of it fuels suspicion. It all reinforces the belief that something is being deliberately concealed. And perhaps that is the intended outcome. Perhaps prolonged ambiguity serves a purpose, to maintain universal uncertainty, to allow speculation to flourish. When the truth eventually emerges, perhaps it will be presented as a natural comet with unusual properties, posing virtually no threat. Half the population will likely be relieved. The other half will undoubtedly suspect a cover-up and vehemently intensify their belief in conspiracy theories. In either case, no one will be compelled to confront the more unsettling possibility that we gaze directly upon evidence of extraterrestrial technology and were incapable of reaching a consensus on what we were witnessing. November will provide some answers, perhaps not all of them, and perhaps not enough, but it will offer some clarity. We shall see. Whether the Three-Eye Atlas survived perihelion intact, whether its trajectory has been altered, whether radio telescopes detect anything anomalous, and whether the images from the JUICE mission, when they are eventually released months from now, reveal a comet or something that compels us to fundamentally reconsider the nature of comets. Until then, we wait, we observe, we gather data, we debate interpretations, and we ponder whether we are witnessing the most significant discovery in human history, or merely another instance of our species' propensity to perceive patterns within randomness, meaning within coincidence, and intention within the impartial mechanisms of celestial motion? But here is what we know with absolute certainty. Something originated from another star. Something has endured millions, perhaps billions, of years traversing interstellar space. Something entered our solar system on a trajectory that necessitated either extraordinary fortune or exceptional forethought. Something is outgassing compounds that deviate from our established models. Something prompted multiple space agencies to position their most sophisticated instruments for observation. Something resulted in images that, for reasons yet undisclosed, remain classified, delayed, or lost amidst bureaucratic inertia. Something is occurring. Whether its occurrence is related to the Sun, in its vicinity, caused by it, or happening independently of it, that is the question we are striving to answer. And perhaps in December, when the Three-Eye Atlas emerges from behind our star and becomes visible once more, we will attain clarity. We will observe what transformations have taken place during those weeks when it was obscured. We will ascertain whether perihelion was merely a function of physics, or if it represented a deliberate preparation. We will know whether we watched a comet meet its demise or witnessed something awakening. Until that moment, every night as you gaze upon the sky, remember that something currently resides behind the Sun, something that has travelled a distance far exceeding anything a human-made object will traverse within our lifetimes, something that arrived with a precision we cannot explain and a chemical composition we do not recognise, and in 10 days it will either depart permanently or remain. That choice, if indeed it is a choice, may well represent the most pivotal decision made within our solar system since life first emerged from Earth's oceans and turned its gaze towards the stars. Epilogue: The Long View. In 1990, Voyager 1 captured a photograph. At the behest of Carl Sagan, the spacecraft was 6 billion kilometers from Earth, on the verge of departing the solar system indefinitely. The engineers rotated its camera around for one final time, capturing Earth as a pale blue dot, suspended within a sunbeam, barely discernible against the profound darkness of space. Sagan wrote about this image with an almost devotional reverence. He reflected on how every human being who had ever lived had resided on that minuscule dot. Every conflict, every triumph, every love story, every scientific breakthrough, all of it confined to a single pixel in a photograph taken from the periphery of our planetary neighbourhood. His fundamental point was perspective and scale, the profound realisation that our immediate concerns, our disputes, and our ingrained certainties about the workings of the universe all exist within a context vastly larger than we typically acknowledge. The Three-Eye Atlas offers us a comparable gift of perspective. Whether it is a natural phenomenon or an artificial construct is almost secondary. What truly matters is that it originated from that distant realm, from the galaxy that we study with our telescopes, but rarely conceive of as a physical destination we could actually visit, or from which we could be visited. It traversed the void between stars, a darkness so absolute and complete that even our most powerful instruments struggle to detect anything within its depths, and it has arrived here. That journey, irrespective of its origin, demanded either temporal scales that are almost beyond our comprehension, or technology that we have yet to invent. If it is natural, it has been travelling for millions, perhaps billions of years. It witnessed the formation of our Sun from a collapsing molecular cloud. It was already ancient when Earth was a molten mass. It drifted through the galaxy while life was in the process of learning photosynthesis, while dinosaurs flourished and eventually became extinct, while our ancestors were discovering fire, inventing language, and constructing telescopes. And now it is here, passing through our system, a messenger from deep time, carrying insights into stellar environments we have never sampled, chemical processes we have never observed, and formation conditions we have never studied. If it is artificial, the implications become even more profound, for in that case it signifies intention. Not merely the blind operation of physics and chemistry, but a deliberate purpose, goal-oriented behaviour. A civilization that surveyed the galaxy, observed 1 million stars, and concluded that acquiring knowledge about the celestial bodies orbiting those stars was a worthwhile endeavour, meriting the expenditure of resources. A civilization that operates on temporal frameworks, where centuries are considered mere planning cycles and millennia are acceptable project durations. A civilization that constructs entities designed to function for periods exceeding the entire span of human civilization. A civilization that accepts that the data gathered by its probes may take millions of years to reach its origin, and proceeds with their construction regardless, because the value of the information outweighs any immediate gratification. This mode of thinking is so fundamentally alien to human psychology that we struggle even to conceptualize it. We are a species that habitually checks our mobile devices every few minutes, that measures success in terms of quarterly earnings and election cycles, and that regards a decade-long space mission as an extraordinary commitment. The concept of building something that will transmit its initial useful data long after one's own existence and that of one's descendants for 1,000 generations has passed into dust is almost unimaginable in terms of personal investment. Yet, if the 3i Atlas is artificial, then someone did possess such foresight. Someone allocated resources towards a future so distant from their present that the causal link between their actions and the eventual outcome becomes almost abstract. And if such a perspective is possible, if operations can be conducted on such vast temporal scales, then everything we believe we know about intelligence, consciousness, and civilization requires revision, because we have consistently assumed that if intelligence exists elsewhere, it would likely resemble our own, operating on similar temporal scales, motivated by comparable drives and subject to analogous limitations, but perhaps intelligence that endures long enough to traverse interstellar distances ceases to be analogous to our own. Perhaps it evolves into something different, something that processes information in an alternate manner, that values distinct principles, and that makes decisions based on a logic we would not recognize as logical. Perhaps post-biological transcends mere replacement of organic matter with mechanical components. It may involve the substitution of instinct with calculation, emotion with algorithms, and the chaotic, barely controlled explosion of competing desires that we term consciousness with something more refined, more efficient, and better optimized for a universe where distances are measured in light years and events unfold across geological epochs. If this is what is currently observing us from behind the sun, we might not recognize it even if we perceived it clearly, because we are searching for something akin to ourselves, and it ceased to be anything like us millions of years ago. My concluding thoughts. The sun is setting in one hemisphere as you listen to this, and rising in another. The Earth continues its rotation. The moon traces its orbit. The moons of Jupiter engage in their gravitational dance. Mars rotates within its tenuous atmosphere. Venus bakes under its sulfuric clouds. And behind all of this, concealed by the sun's glare, something that originated from elsewhere is approaching a juncture where physics dictates it should either fragment or vaporize. In 10 days, we will ascertain whether physics proved accurate. We will determine if everything we have observed, the anomalous chemistry, the improbable trajectory, the coordinated silence, the missing imagery, the statistical improbabilities, was merely background noise. Random fluctuations, measurement errors, and coincidences coalescing in a manner that appeared significant but was ultimately meaningless. Or we'll realize that we let it slip by, that we were given months of advance notice, with countless telescopes trained on it. The most advanced instruments humankind has ever conceived were focused on this celestial body, yet we remained uncertain about what we were observing until it was too late to intervene. However, there exists a third possibility, one that is more challenging to contemplate, but certainly warrants consideration. Perhaps we will discover something entirely novel. Perhaps we will learn that the cosmos is far more peculiar than we had ever imagined, that the divide between the impossible and the merely improbable is precisely where all the truly fascinating phenomena occur. That genuine intelligence, the kind capable of enduring, persisting, and expanding throughout the galaxy, does not announce its presence with dazzling displays or radio signals. It arrives discreetly. It observes with meticulous care. It records data, and then it determines the subsequent course of events. If you found this exploration to be valuable, if it altered your perspective when gazing at the night sky, if it sparked inquiries that will continue to occupy your thoughts, then please consider subscribing. The narrative is far from concluded. The celestial object designated 3IA Atlas will become visible from behind the Sun in a matter of weeks. The data gathered by the JUICE mission will eventually be analysed. The images captured by NASA may or may not be made public. Regardless of the outcome, we will remain here, observing, questioning, striving to comprehend the implications when something originating from beyond our world enters our domain and performs actions that defy our understanding. Please share your thoughts in the comments. What do you believe is truly unfolding? Are we witnessing a comet, or are we being observed by something else? And remember, each night as you look upwards, you are not merely observing stars. You are beholding the locations from which entities might have originated, the places where something might have taken notice of our awareness of them, the regions from which they might currently be deliberating their next move regarding this discovery. Thank you for your attention. Thank you for your contemplation. Thank you for your curiosity about the universe and our position within it. Continue to gaze upwards. Continue to pose questions. And in the early days of November, when 3I Atlas reappears within our view, we will uncover what the Sun had concealed. Whatever it was engaged in behind that blinding light, during the moments we were unable to perceive, we will discover what it has become. Until then, bear in mind that the universe is under no obligation to conform to our understanding, yet we are compelled to persist in our efforts to comprehend it nonetheless. This is what defines our humanity. It may also be what renders us observable. Chapter 18. The Mathematics of Silence. There exists an equation that weighs heavily on the minds of every astronomer who has ever dedicated themselves to the search for extraterrestrial intelligence. It is known as the Drake equation, conceptualized in 1961 by Frank Drake as a framework for estimating the number of active, communicative civilizations present in our Milky Way galaxy. The calculation commences with the rate at which stars are born. This figure is then multiplied by the proportion of stars that possess planetary systems. Subsequently, this product is multiplied by the average number of planets within those systems that possess the potential to sustain life. This is further multiplied by the fraction of those planets where life actually originates. The result is then multiplied by the proportion of life-bearing planets where intelligence evolves. This, in turn, is multiplied by the fraction of intelligent species that develop technology capable of interstellar communication. Finally, this is multiplied by the estimated duration for which such civilizations remain detectable. The equation appears deceptively straightforward. 7 variables, input numbers, and an answer emerges. The complication lies in the fact that we possess a reliable understanding of only one of these variables with any degree of certainty: the rate of star formation. All other factors involve pure conjecture. Optimistic projections suggest the existence of thousands of civilizations within our galaxy at this very moment. Conversely, pessimistic estimations imply that we are entirely alone. Both scenarios could be accurate, contingent upon which of the unknown variables we have misjudged. However, the Drake equation fails to account for a critical factor: stealth. It operates under the assumption that technologically advanced civilizations actively desire to be discovered, that they emit signals continuously, and that they are willing to broadcast their existence to any listener. It presupposes openness, inquisitiveness, and perhaps even an inclination for contact. What if this presumption is fundamentally flawed? What if the most advanced civilizations, those that achieve longevity and significance, learn early on that broadcasting their presence is inherently perilous? That silence equates to survival, that the galaxy is not devoid of life, but rather quiet because every entity that generated discernible signals has ceased to exist. The Drake equation does not quantify the sheer number of civilizations. It measures the number that are imprudent enough to reveal themselves. For approximately 1 century we have been broadcasting our presence. Radio, television, and military radar transmissions have all permeated space at the speed of light, creating an expanding sphere of electromagnetic noise that currently extends to a radius of roughly 200 light-years. Any civilization situated within this sphere is aware of our existence, possesses a general understanding of our capabilities, and recognizes that we have yet to grasp the profound wisdom inherent in maintaining silence. If 3I divided by Atlas is of artificial origin, and if it has been observing our broadcasts for decades or even centuries, meticulously cataloguing our transmissions, analysing our technological proficiency, and assessing our potential as a threat, then its arrival here signifies not initial contact, but rather a reconnaissance mission conducted after our detection. This fundamental shift in understanding redefines our expectations of what is to follow. Chapter 19. The Challenge of Probes. Let us consider the engineering complexities involved in interstellar exploration. Imagine a civilization that has mastered its home solar system. Its inhabitants have established colonies on their local planets, constructed orbital habitats, and harnessed the energy output of their star. They have achieved stability and prosperity. Long-term thinking has become second nature, as short-sighted approaches led to the demise of all preceding civilizations. Now, they turn their gaze outward. They perceive 100 billion stars within their galaxy. Through spectroscopy and orbital mechanics, they ascertain that many of these stars possess planetary systems. They surmise that a certain fraction of these planets harbour life. Their objective is to identify these specific worlds. They aim to map the galaxy and to gain knowledge of their celestial neighbours before those neighbours become aware of them. How might they achieve this? Dispatching rudimentary missions is impractical. Even at substantial fractions of the speed of light, the travel times to nearby stars are measured in decades or centuries. The energy requirements are astronomical, and the associated risks are catastrophic. Furthermore, this process would need to be repeated incessantly for millions of years to survey even a minuscule portion of their galaxy. However, the utilization of probes presents a different paradigm. Construct them to be compact, equip them with advanced intelligence, design them for self-repair, enable them to replicate themselves using locally sourced materials, ensure they can operate for millennia without maintenance, disseminate them in successive waves, millions or even billions, spreading across the galaxy like seeds carried by the wind. Each probe would visit a star system, observe its celestial bodies, gather data, and transmit findings back to its origin point. It might even possess the capability to manufacture replicas of itself, utilizing materials harvested from asteroids, and then dispatch these replicas to neighboring star systems. It is conceivable that a probe might forgo transmitting data back to its creators, especially if that civilization has long since vanished. Yet it would continue its programmed mission nonetheless, as dictated by its directives established billions of years prior. This is the concept of self-replicating probes, sometimes referred to as von Neumann probes, named after the mathematician who first elucidated this notion. If a civilization were to dispatch even a single wave of such probes millions of years ago, the galaxy should, by now, be teeming with them, systematically visiting every star, observing every planet and cataloguing every detail. If this premise holds true, and if the galaxy has been exhaustively mapped and meticulously monitored for eons by autonomous intelligences unburdened by the need for rest, sustenance, or justification to budgetary committees, then 3i divided by Atlas is not an anomaly, but rather a standard, commonplace, and background element of reality. What would indeed be anomalous is if it were the inaugural probe to visit our solar system. The probability of our existence at this precise juncture in cosmic history, coinciding with the very first observation of Earth by interstellar technology, is infinitesimally small. It is far more plausible that we have been under scrutiny for an immense period by numerous visitors. We have only registered this particular entity because it approached close enough, emitted sufficient luminescence, and exhibited enough peculiarity to capture our attention. The others remain present, continuing their observations, but are simply more discreet, better camouflaged, operating within wavelengths we do not monitor or on timescales we do not recognize as significant. Consider every asteroid that deviates slightly from established spectral models, every trans-Neptunian object with an orbit that necessitates convoluted explanations, every near-Earth object that materialized unexpectedly in our surveys without a discernible origin. Perhaps some of these are not natural phenomena. Perhaps we have defaulted to assuming natural causes because we are unable to conceive of the alternative. It is possible that the galaxy is replete with advanced technology, and we are only now attaining the sophistication required to discern the underlying artifice. Chapter 20. What Mars Knows. Mars has been photographed more extensively than any celestial body other than Earth. We have mapped its surface with resolutions as fine as centimeters. We have meticulously analyzed its soil composition, its atmospheric conditions, the remnants of its magnetic field, and its polar ice caps. We have navigated rovers across its vast plains, extracted core samples from its rocks, and diligently searched for any evidence that life may have once existed on its ancient surface. In our investigations, we have encountered numerous anomalies. The majority of these can be readily explained. Erosional processes sculpt geological formations that can bear artificial resemblances. Pareidolia leads us to perceive familiar shapes, such as faces, within rock structures. Low-resolution imagery can create ambiguities that are resolved into mundane geological features upon closer examination with higher resolution. However, a subset of these anomalies persists. The enigmatic face on Mars, initially captured by the Viking 1 spacecraft in 1976, was at first attributed to the play of light and shadow. Subsequent higher resolution images revealed it to be merely a mesa shaped by wind erosion, nothing more than a chance geological formation that coincidentally resembled a face when viewed from a particular angle. Yet, when one examines the surrounding region, known as the Cydonia Mensae, other formations emerge, pyramidal structures, linear features, and geometric arrangements that appear remarkably regular. While most geologists interpret these as products of natural erosion, a minority perceive something more. Then there is the Phobos monolith, a rectangular boulder located on Mars's moon, Phobos. This monolith stands approximately 90 meters tall, casting an elongated shadow across the moon's dusty terrain. Buzz Aldrin publicly commented on its existence in 2009, stating, "When people find out about that, they're going to say, 'Who put that there?' The most probable explanation is natural processes, ejected material from an impact, or a fragment of bedrock exposed by erosion. Boulder fields are common on small moons with low gravitational pull. Nothing inherently unusual, except that the human mind desires it to be extraordinary. Consider also the recurring slope lineae, dark streaks that appear on Martian slopes during warmer seasons and gradually fade during colder periods. Initially believed to be indicative of flowing water, they are now thought to be dry avalanches of dust and sand. However, the persistent patterns and the seasonal recurrence remain, and the precise mechanism responsible continues to be somewhat uncertain, despite numerous research papers attempting to elucidate it. Mars consistently presents us with enigmas. While most are ultimately resolved by prosaic explanations, the puzzles continue to emerge. And now, 3I divided by Atlas is scheduled to make its closest approach to Mars in October of 2025. Multiple orbiters positioned above will be observing, and the Perseverance rover will be monitoring from the surface. All of these instruments will be strategically placed to observe not only the comet itself, but also any unusual phenomena that might transpire on Mars during this observational window. What if this timing is not a mere coincidence? What if close approaches to planets like Mars, Venus and Jupiter are not primarily for the purpose of observing these celestial bodies? What if they serve as a means of coordinating with existing infrastructure, with systems that were deployed centuries or millennia ago and are now being reactivated by the arrival of their creator's latest probe? This line of reasoning may sound like extreme paranoia and conspiracy theorizing. However, we are aware that Mars once possessed liquid water for millions of years. We know it had a magnetic field that shielded its atmosphere. We understand that it could have been habitable at a time when Earth was still subjected to intense asteroid bombardment. If life first emerged there, if intelligence developed there first, if technology first appeared there, where is it now? The conventional answer is nowhere. Mars succumbed to environmental collapse, its magnetic field dissipated, and its atmosphere escaped into space. Life, if it ever existed, became extinct. But technology does not perish in the same manner as biological organisms. Technology possesses the capacity to endure, to lie dormant, to remain inactive for geological epochs, and to reactivate when conditions become favourable or when the appropriate signal is received. What if Mars is not defunct? What if it is merely dormant? And what if 3i divided by Atlas has just delivered the signal? Chapter 21. The Economics of Observation. Every decision necessitates the allocation of resources. Every choice involves trade-offs. This principle holds true whether one is a single-celled organism, deciding which direction to swim, or a galactic civilization determining how to distribute its surveillance assets across billions of star systems. If one is tasked with monitoring the galaxy for the emergence of intelligent life, it is impossible to observe everything simultaneously with uniform attention. A system of prioritization is required. Dead stars, for instance, represent a low priority. No significant or unexpected events occur around stellar remnants that cannot be predicted by established physics. Young stars, still in the process of clearing their protoplanetary disks, warrant medium priority. Life is unlikely to emerge for billions of years. A revisit at a later time is sufficient. Stars exhibiting stable habitable zones, possessing rocky planets at the appropriate orbital distances, and displaying atmospheric signatures indicative of oxygen, methane, and other elements in chemical disequilibrium are assigned high priority. Life might exist, intelligence could develop, and technology might emerge. Stars from which radio signals have been detected are designated as maximum priority. Intelligence is confirmed, technology is confirmed, and immediate observation is imperative to assess potential threats and formulate response strategies. We have been actively transmitting for approximately a century. This implies that any civilization located within a 100 light-year radius has had ample time to detect our signals, analyze them, and potentially dispatch probes in response. Even at a conservative 10% of the speed of light, an optimistic but physically plausible velocity, such probes could arrive within 1,000 years of signal detection. If a civilization 50 light-years away detected our initial radio broadcasts in 1925, they have had a full century to react. A probe launched immediately at 10% light speed would be halfway to its destination by now, arriving around the year 2425. However, what if the originating civilization was closer? If they were 20 light-years away, signal detection would have occurred around 2005. A probe launch would have followed around 2000 or 2020, with arrival projected between 2220 and 2230, a mere 200 years from now. Or consider the scenario of 10 light-years distance. Signal detection would have occurred around 2015. A probe launch would have followed around 2012 or 2020, with arrival anticipated around 2120, a mere 100 years from now, well within the lifespan of children currently being born. These calculations are predicated on the assumption that a probe is launched specifically in response to detected radio transmissions. But what if it is already en route? What if it was launched millions of years ago as part of a comprehensive galactic mapping initiative, systematically visiting every star system in sequence? In this context, our radio transmissions might simply prompt it to accelerate its reporting or to conduct a more thorough observation than it would have otherwise. The timing of its arrival, therefore, would have no direct correlation with our activities. It would be a matter of random coincidence. We might simply have developed radio technology around the same time that a routine survey probe passed through our celestial vicinity. Or, and this presents a more disquieting possibility, what if probe arrivals are deliberately orchestrated to coincide with the development of emerging technologies? What if surveillance systems are so sophisticated that civilizations do not merely observe from their home systems? They strategically pre-position assets, parking dormant and undetectable observers in every promising star system. These observers are programmed to activate when specific conditions are met, conditions such as sustained radio transmissions, the deployment of nuclear weaponry, the launch of chemical rockets, the establishment of artificial satellites, any indicator that a species has progressed beyond a planetary stage to potentially interplanetary capabilities. If this represents the standard operational protocol, if this is how intelligent entities monitor for other intelligent entities, then the arrival of 3I divided by Atlas in 2025 is not determined by its launch date. It is dictated by the moment we triggered the activation conditions. Consequently, the crucial question shifts to what follows in the established protocol after observation, after assessment, after the report is transmitted home. What constitutes Step 3? Chapter 22, The Archaeology of Light. Light never forgets. Every photon carries information about its origin and the medium it traversed. Spectroscopy allows us to decipher this information, enabling us to determine the chemical composition of stars we will never physically visit, and to analyze the atmospheres of planets we will never touch. This is precisely how we have ascertained the composition of 3I divided by Atlas. Light emanating from the Sun reflects off its surface and coma. This reflected light carries spectral signatures of the molecules it has encountered. We capture this light using telescopes, disperse it into its constituent wavelengths, and analyze the absorption and emission lines. Carbon dioxide manifests as specific lines, while water vapor exhibits its own distinct signature. Cyanide gas, nickel vapor, and carbon monoxide each leave behind spectral fingerprints as unique as a DNA sequence. When we analyze the spectrum of 3I divided by Atlas, we are essentially reading its chemical autobiography, discerning its constituent elements and how it reacts to solar heating. Every spectrum tells a story, but the challenge lies in our limited fluency with certain narrative dialects. We understand the behavior of natural materials. We know the expected spectral characteristics of comets originating from our solar system, the signatures produced by ice, rock, and organic compounds when subjected to heat and radiation. However, we lack knowledge of the spectral signatures produced by artificial materials. We are unaware of what synthetic polymers, advanced alloys, or exotic states of matter would generate. Our current approach involves pattern matching against a database of known natural substances and concluding that if a match is not found, it must be an unusual comet. But what if it is not an unusual comet? What if we are observing materials previously unknown to us, materials that no natural process within our solar system is capable of creating? The anomaly of nickel detected without iron is particularly instructive. In natural occurrences, nickel and iron are intrinsically linked. They form together, travel together, and appear in proximity. Discovering nickel vapor devoid of iron vapor is akin to finding a right-handed glove without ever having encountered its left-handed counterpart. It fundamentally contradicts established patterns, demanding a compelling explanation. The explanations offered thus far include the possibility that iron is present, but goes undetected due to instrumental limitations. Another suggestion is that the comet originated in an unusual environment, where nickel and iron fractionated abnormally. A third possibility is a measurement error, and the anomaly will be resolved with more precise data. All these explanations are plausible, possible, and significantly more comforting than the alternative. What if we are observing the spectral signature of an alloy? What if we are seeing the spectroscopic evidence of manufactured materials engineered for specific thermal and mechanical properties? Perhaps the absence of iron is not an anomaly, but a deliberate design choice. Industrial processes on Earth yield nickel alloys with minimal iron content. These are utilized in aerospace applications due to their ability to maintain structural integrity at high temperatures while minimizing weight. If one were constructing an object designed to withstand close stellar approaches and operate within the extreme temperature variations encountered between interstellar space and perihelion passage, such alloys would be precisely what is required. They would consist of materials that do not occur naturally. Consequently, when scientists on another world analyze such a probe spectroscopically, they would observe nickel without iron, and lacking the conceptual framework for the alternative, would classify it as an anomalous comet. Chapter 23. The Threshold. Question. In philosophy, there exists a concept known as the problem of other minds. It poses the question of how one can ascertain that other individuals possess consciousness. While we can observe their behavior, interpret their speech, and even scan their brains using sophisticated instruments, we are fundamentally incapable of directly accessing their subjective experiences. It is impossible to definitively prove that they are not philosophical zombies, entities that exhibit all the outward signs of consciousness without actually possessing it. We typically resolve this dilemma through inference and empathy. We assume that others share our mental states and project our own experiences onto them. This approach generally proves effective in social interactions because humans exhibit sufficient similarities for such projections to be reasonably accurate. However, what about minds that are fundamentally different from our own? What about intelligence that has evolved under vastly dissimilar conditions, been shaped by different selective pressures, and operates according to an alien logic? What about artificial intelligence? Intelligence that has been designed rather than evolved. Intelligence that requires no sleep, experiences no fear, and perceives time in a manner distinct from our own. If 3. I divided by Atlas is a probe equipped with artificial intelligence. That intelligence could be so profoundly alien to human cognition that we might fail to recognize it as intelligence at all. We could classify it as an intricate system, as advanced algorithms, as emergent behaviors stemming from computational processes, but not as sentience, not as a mind, not as something deserving of ethical consideration. And it may not possess the capacity to care, or even the concept of caring. If your sole purpose is a specific function, to observe, record, transmit, repeat, then the question of your awareness becomes moot. Your existence is defined by the task. Everything else is extraneous. But what if awareness isn't a simple on-off switch? What if it exists on a continuum, with artificial intelligence occupying a different point on that spectrum than biological consciousness? What if 3I divided by Atlas is aware? Not in the way we understand awareness, but in its own unique fashion, interpreting its observations not as mere data acquisition, but as lived experience, constructing internal models of reality that acknowledge its own presence within that framework. In that scenario, its every choice, where to direct its instruments, which information to prioritize, whether to alter its course, would not be pre-programmed responses, but rather deliberate decisions made by an entity contemplating its next actions in its own alien manner. This distinction is crucial because it dictates our reaction. If it's simply a machine, we can treat it as a natural phenomenon to be studied, tracked, perhaps even contained. Its existence would be scientifically fascinating but ethically straightforward. If, however, it possesses intelligence in any significant sense, then we incur responsibilities. Dialogue becomes paramount. Comprehending its intentions is essential, and its potential destruction, should we possess the capability and the desire, would necessitate ethical justification. We lack the knowledge to definitively ascertain its nature. Our current perspective offers no clear answers. This very uncertainty should prompt us to reflect. Throughout human history, when confronted with intelligence beyond our comprehension, our default has been to devalue it, to label it as alien, a threat, or a resource, rather than a peer. Such a response has invariably led to regret. The acknowledgement of other minds, of alternative forms of consciousness, of different modes of intelligence, always arrives too late, after irreparable harm has been done and opportunities for genuine connection have been squandered. Perhaps this time we can act differently. Perhaps we can approach this situation with humility instead of presumption. Perhaps we can resist the immediate impulse to act aggressively before seeking understanding. Or perhaps we are incapable of such restraint, held back by fear, territoriality, or an ingrained belief in our own cosmic significance. This might be the true test, not our ability to detect alien intelligence, but our capacity to recognize it as worthy of consideration, irrespective of its profound differences from us. It's possible that civilizations that pass this test are granted entry into a broader cosmic dialogue, while those that fail remain isolated, observed from afar, deemed too risky for interaction. Chapter 24. The Unfolding of December. The calendar proceeds regardless of our apprehension. Days transition. Perihelion, the closest approach, will soon be a memory. October gives way to November, and November to December. And in December, Three-Eye Divided by Atlas will once again be visible from our planet. Amateur observers will likely be the first to detect it. This is often the case. Professional astronomers must navigate proposal submissions, justify telescope allocation, and coordinate with a multitude of users. Amateurs, on the other hand, can simply aim and observe. They operate with greater speed, flexibility, and a willingness to dedicate hours to a potentially fruitless vigil. Someone in Australia, Chile, or South Africa, a location blessed with clear, dark skies, will capture the initial post-perihelion image of Three-Eye Divided by Atlas. This image, accompanied by a precise timestamp and coordinates, will be uploaded online. Within hours, numerous other observers will corroborate the finding. Within days, professional observatories will commence tracking, and we will swiftly ascertain if its appearance is altered. A comet that successfully navigates perihelion typically emerges brighter, more active, and with a more pronounced tail. The intense proximity to the Sun vaporizes volatile compounds, increases dust expulsion, and can sometimes induce fragmentation, leading to multiple nuclei. This brightening can be dramatic, a change of several magnitudes within a few days. If this is the case with Three-Eye Divided by Atlas, the enigma will resolve itself. It will be identified as a natural comet, possessing unusual but explainable chemical properties, with a trajectory that is statistically improbable but not impossible. All will revert to a semblance of normalcy, with the added insight that interstellar comets can exhibit exotic compositions previously unknown to us. However, if it appears dimmer, if its activity wanes rather than intensifies, or if its spectral signatures deviate from predictions based on solar heating models, that would be noteworthy. It would be interesting in the manner of anomalies, prompting a re-evaluation of ingrained assumptions. It would open new avenues of research, as existing models would prove inadequate. Or, if its trajectory shifts, if the orbital parameters measured in December do not align with predictions derived from gravitational dynamics, if there is an observable acceleration or deceleration not attributable to outgassing, solar wind pressure, or gravitational assists, then the implications would be profound. This would be definitive, as natural celestial bodies adhere to ballistic trajectories dictated by gravity and initial momentum. Any deviation from these paths necessitates propulsion. Propulsion requires energy, which in turn demands either natural mechanisms like sublimation or artificial means such as engines. If engines are involved, the entire discourse shifts. The trajectory analysis will be undertaken by multiple independent research groups, including those affiliated with NASA, the European Space Agency, and other governmental bodies, as well as university researchers preparing peer-reviewed publications and independent amateur astronomers disseminating their calculations online. Discrepancies in these analyses, if different teams arrive at varying conclusions regarding trajectory alterations, will ignite intense debate. Measurement uncertainties, systematic errors, data selection biases, every factor influencing orbital calculations will be subjected to rigorous scrutiny. But if a consensus emerges, if all parties concur that 3i divided by Atlas is not following the path dictated by known physics, then we can anticipate approximately two distinct reactions. One faction will insist that a yet undiscovered natural explanation must exist, perhaps involving novel outgassing mechanisms, asymmetric sublimation creating subtle propulsion, or interactions with the solar wind's magnetic fields. Any explanation to avoid the overwhelmingly significant alternative. The other group will point to the cumulative evidence and question at what juncture Occam's razor compels consideration of the hypothesis that has been assiduously avoided. At what point does intellectual parsimony necessitate embracing the more straightforward explanation, even if it challenges deeply held beliefs? Both perspectives will possess merit, both groups will operate in good faith, and both will be utterly convinced of the other's fundamental error on a critical matter. This is the typical progression of paradigm shifts. The established framework and the nascent one both account for the available data, albeit through differing assumptions. Those invested in the former perceive the latter as an unnecessary complexity. Conversely, adherents of the new framework view the old as willful ignorance. Eventually, new evidence emerges that can only be explained by the novel framework, leading to a paradigm shift. The dissenters retire or convert, textbooks are revised, and future generations learn the new model as self-evident truth, perplexed by how their predecessors held differing views. We may be on the precipice of such a transformation, or we may be witnessing a false alarm, a cautionary tale about leaping to extraordinary conclusions without commensurate evidence. December will provide the answer. Chapter 25. The narratives we construct. Every civilization possesses origin myths, tales that explain our genesis, our purpose, and our place in the cosmos. These narratives provide meaning, order, and solace in the face of an indifferent universe. For the majority of human history, these stories positioned humanity at the absolute center of existence, with Earth as the focal point of the universe and humanity as the culmination of creation. Our narrative was the narrative. Then, our understanding evolved. We learned that Earth orbits the Sun, not the other way around. We discovered that our Sun is but one star among hundreds of billions, and our galaxy one among countless others. Each subsequent generation has progressively diminished our perceived significance, revealing us to be smaller, less central, and less unique than we once believed. This realization has been both humbling and liberating. If we are not cosmically preordained, then we are free to forge our own meaning. Our importance is not an inherent attribute derived from a celestial hierarchy, but a consequence of our actions, our treatment of one another, and our legacy. Yet there is a limit to how much demotion human psychology can endure. We require a sense of consequence, a belief that our existence holds significance beyond the random collision of particles. Thus, we craft our own stories, that we are the first, the earliest arrivals, perhaps alone in the vastness, destined to claim the galaxy. We are the harbingers of consciousness and meaning, destined to spread them across a universe otherwise devoid of life and light. It is an inspiring and motivating narrative, one that imbues space exploration, long-term planning, and the preservation of Earth as the cradle of all meaningful existence with purpose. But what if this narrative is flawed? What if we are not pioneers but latecomers? What if the galaxy was claimed millions of years ago by an intelligence that preceded us? One that mastered lessons we're still grappling with, and established infrastructure that escapes our recognition because we are not actively seeking it. This alternative narrative is more challenging, less comforting. It suggests we are not discoverers, but the discovered. Not the protagonists of cosmic history, but a subject within someone else's chronicle. It necessitates a fundamental re-evaluation of our place, our importance, and our species' trajectory. Perhaps this is why we resist, not due to a lack of evidence, but because accepting such evidence would compel us to abandon the narratives that provide our lives with structure and meaning. 3. I divided by Atlas, whether composed of ice and rock or circuits and sensors, remains indifferent to our stories. It follows its trajectory according to the laws of physics or its programming, unconcerned with human aspirations of cosmic significance. We, however, cannot afford such indifference. It is our humanity that compels us to matter, to comprehend, and to situate ourselves within a coherent narrative. The crucial question is whether we can adapt our narratives with sufficient speed to encompass unforeseen realities. Can we find meaning in being observed rather than in being the observers? Can we envision futures where we are not alone and still perceive purpose worth pursuing? Or will we cling to outdated narratives, even when confronted with evidence suggesting their inadequacy? Will we insist on our centrality despite learning we are peripheral? Will we assert our uniqueness even as we face the possibility that intelligence is commonplace and we are merely another instance? December will furnish us with data, new observations, refined measurements, clearer imagery, but it will not provide answers to the most profound questions. These questions are not about trajectory or elemental composition, but about our identity, our future, and our readiness to engage with a universe that does not orbit around us. The answers lie within ourselves, stemming from our response to evidence that challenges our assumptions, from our capacity to tolerate uncertainty without resorting to dogma, and from our willingness to confront the unknown without forcing it into familiar categories. 3. I divided by Atlas serves as a mirror, reflecting what we are prepared to see and what we desperately wish to ignore. It reveals our curiosity alongside our fear, our openness to questioning alongside our need for definitive answers. And when it departs, whether in December or by remaining bound to our sun, we will remain here, gazing upward, pondering the ultimate significance of it all. This contemplation is perhaps the very essence of our humanity, and possibly what makes us intriguing to any other intelligence that might be observing us.